Beware, many of these false beliefs even seem plausible. Although we now know more than ever about the universe, many of us continue to be misled by a number of common myths. Recent astronomical research and discoveries have disproved some of these space myths. Black holes are bad. Even light cannot escape the gravitational attraction of black holes because it is too strong. They destroy the atoms that make up stars, ripping away layers of gas in the process. They are frequently pictured as enormous cosmic vacuum cleaners that can clear out wide swaths of space. The black holes in science fiction and reality, however, do not always resemble one another. The behavior of black holes is actually very similar to that of any other large object in the cosmos. The escape velocity is the speed needed to break free from an object's gravitational influence, be it a planet or a black hole. An object just needs to move at a speed of 384 miles, 618 kilometers per second to escape the sun's weak gravitational pull. The item will revert to falling toward the solar surface if this speed cannot be attained. Even if anything were moving at the speed of light, which is approximately 186,411 miles, 300,000 kilometers per second, it would not be able to escape the event horizon and would have to continue inward. The escape velocity decreases with increasing distance from an object, and far from the event horizon, black holes act like stars. If the sun were exchanged with a black hole of the same mass right now, Earth would still orbit the star as it does now because objects traveling far enough away and fast enough are not in risk of being drawn into the center. Summertime brings Earth closer to the sun. It is understandable why some people jump to the conclusion that the seasons are influenced by the distance to the sun, given that most people are aware that the Earth doesn't revolve around the sun in a perfect circle. The concept, however, falls apart when you consider that summer occurs at various periods of the year in the northern and southern hemispheres. The distance between Earth and the Sun varies by just 3.1 million miles, 5 million kilometers, in a year, which is only about 3% because Earth's orbit isn't as elliptical as people think. Furthermore, we are really nearer the Sun during the winter in the northern hemisphere than we are during the summer. The axial tilt of the Earth is the true cause of the seasons. Light strikes the northern and southern hemispheres at proportionately different angles and for varying lengths of time each day as the year goes on. Because of the short days and low angle at which the light enters the atmosphere during the winter, the energy is dispersed across the atmosphere as it descends to the ground. In the summer, when the days are longer and the sun is at a steeper angle, the energy is concentrated in a smaller area and travels more directly to the ground. The sun is flamed. Fuel, heat, and oxygen are the three things that fire needs to survive. Since it is primarily made of hydrogen and helium gas, the sun possesses fuel. Hydrogen is incredibly combustible, but helium is an inert element and does not burn like some of its volatile companions on the periodic table. A tremendous amount of heat energy is also produced by the sun, whose surface is around 9,932 degrees Fahrenheit, 5,500 degrees Celsius. The fire triangle for the sun is incomplete, though, because there is no oxygen in outer space. The heat and light that the sun emits are actually the byproducts of thermonuclear fusion, not a fireball like many people believe. High-speed hydrogen atoms approach 1 femtometer apart in the high-pressure, high-heat atmosphere of our star. When two nuclei collide at this distance, they can fuse to generate helium while simultaneously releasing a massive amount of energy in the form of gamma-ray radiation. Every second, 700 million tons of hydrogen collide inside the sun to create 650,000 tons of helium, which in turn sparks further fusion and powers the sun's natural nuclear reactor. The asteroid belt poses a serious risk. There is little doubt that the region of our solar system known as the asteroid belt contains a significant amount of rock. This belt of pieces, which lies between Mars and Jupiter, is made up of more than 750,000 individual asteroids that are each over 3,280 feet, 1,000 meters, in diameter and over 3,000 minor planets. According to the urban legend, any spacecraft that dares to navigate through the belt risks being endangered when the larger asteroids clash, scattering smaller fragments into the belt. Science fiction has fueled this misconception. The odds of successfully navigating an asteroid field are roughly 3,720 to 1. C-3PO advises Han Solo as he pilots the Millennium Falcon into one in Star Wars: The Empire Strikes Back. He could hardly have been more mistaken if the asteroid field on Hoth resembled our own. NASA's Pioneer 10 was the first spacecraft to successfully traverse the asteroid belt in the 1970s. Pioneer was only shielded by a thin layer of aluminum honeycomb, yet despite the seeming risk, it made it through without any issues. The vast distance between asteroids rather than deliberate evasion is at blame. Constellation stars are close together. 9 birds, a dragon, 29 inanimate items, 19 land creatures, and 88 constellations are among the 88 groups of stars that make up the night sky. Since they are so far apart, these unmistakable clusters, which have served as a compass for generations of farmers and travelers, are not truly constellations at all. The stars that make up the constellations, despite appearing to be close together, are frequently far apart by tens or hundreds of light years. Orion would appear to be a warrior with a shield from our vantage point on Earth, but from another part of the galaxy, the stars would appear far apart and disconnected. We only happen to observe them in groups because of their wide range in age, size, type, and brightness. Constellations may not be collections of stars with any particular scientific significance, but they do aid in organizing the sky into discernible and manageable sections. Astronomers sometimes suddenly find it much simpler to remember the names and positions of particular stars by associating star patterns with well-known animals or items. The mythology and background of each constellation helps to cement it in people's memories, making this one among the few times when myths can be beneficial. A dark side to the moon. The moon is not quite what it looks, but studio albums, books, television shows, films, and video games have all been inspired by the dark side of the moon. From Earth, we can only view one side of the moon. Nevertheless, this does not imply that the other side is dark. The moon's phases make this myth simple to refute. At any other time of the month, we can only see a portion of the moon. During a full moon, the side we can see is completely illuminated while the other side is actually completely dark. The remainder of the light is falling on the other side, often known as the black side. You only need to look at the first ever photographs of the far side of the moon, taken in 1959 by the USSR's Luna 3 and showing how it was perfectly illuminated by the sun, to see photographic proof. These photographs revealed that the rock is actually lighter in color than the side we can see, making our side the genuine dark side of the moon, dispelling the notion that the dark side of the moon receives no light. From space, the Great Wall of China is visible. The Great Wall of China, which stretches for an amazing 13,171 miles, is the world's longest man-made construction, 21,196 kilometers. It has been a common belief since the 1930s that it might be visible from space, but sadly, this is only partially accurate. The Great Wall may be quite long, but at just over 20 feet, 6 meters, at its base, it is obviously not even close to being as wide. In addition, it is made of materials that mix in well with the landscape. The wall in low Earth orbit, which begins at a height of 99 miles, 160 kilometers, is apparent to the naked eye but is easily discernible on radar scans. Commander Chris Hadfield tweeted while he was on the International Space Station in March 2013, "Both the Chinese astronauts and I failed to see the Great Wall of China while we were in space. Maybe, given a large enough camera lens and pure air." That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.